Welcome to the Connect with TrueSight webinar series. During today's webinar, you're able to ask questions of our panelists. The questions and answers, along with this webinar recording, will be published to our YouTube channel a week from today's broadcast. Today's topic is TSOM Best Practices for Optimizing TSPS Performance. I'll turn it over to Akash to take us through this content.
Thank you, Greg, and hello everyone. My name is Akash Kalathia. I am a staff specialist technical support analyst, and I have been working at BMC software for over 5 years within the customer support department. I have supported products like Petrol Agent and its knowledge modules, ProactiveNet, and TrueSight operation management. Working in customer support, we get to see a lot of different types of issues, and some of these are in the area of TrueSight presentation server performance. This can be related to configuration, tuning, and sometimes hardware, networking, or even OS related issues. If you are administering and managing TrueSight presentation server, then this webinar is for you. Let's have a look at our agenda today. I will give you a brief overview of TrueSight presentation server. After that, we will go through the best practices to optimize the TSPS performance. We will see what all data you can collect for the BMC support to diagnose the performance issues. We will also have a look at some of the common issues that we have seen in this area. The TrueSight presentation server hosts the web-based TrueSight console, which consumes event and performance data from different data providers to deliver a consolidated set of views for monitoring. It also performs functions such as role-based access control, data management functions such as storage and persistence. User management and multi-tenancy support are also enabled through integration with Remedy single sign-on. There are mainly two data stores that TSPS uses: PostgreSQL Server and Elasticsearch. PostgreSQL Server stores the information such as data provider servers, devices, groups, application model entities and its relationships, and entities such as Petrol Agent and Integration Service Host. On the other hand, Elasticsearch persists and searches the events received from the data providers. This diagram shows how it fits in with the other BMC TrueSight operation management components. You may notice sometimes that the TrueSight console is a bit sluggish while performing some operations. One or more processes of TrueSight presentation server might be using a lot of CPU, which can also result in overall slowness of response time when accessing the console. One or more processes might be using a high memory and eventually may run out of memory, resulting in a crash. When this happens, you will see a hprof created under TrueSight home logs directory. hprof is nothing but basically a heap memory dump of Java process. To avoid this kind of issues, as a first step, we need to make sure that the TSPS server is tuned and optimized for the best performance as per the sizing of the environment. Let's have a look at some of the best practices checklists that you can follow in case of such issues. First thing to make sure is that your environment is sized correctly and has adequate hardware resources. Having a fewer hardware resources than what is recommended by BMC can lead to multiple performance issues. The table on the right hand side represents the maximum value recommended for each parameter based on the environment type. The number of components connected to the TrueSight presentation server can vary depending on the deployment type, and it does not affect these values. For example, you may have 4 to 5 TSIMs connected to a single TSPS server, but the maximum values recommended for each parameter here should not exceed per TSPS. So let's say number of devices per TSPS should not exceed 60,000 for a medium environment. If it exceeds the limit of 60,000, then you need to retune your TSPS as per the large environment configurations. And for a larger environment, a number of devices should not exceed the limit of 120,000. Same goes for all the other parameters that are listed in this table. BMC has developed a HealthCheck tool which compares the current TSPS configurations to BMC's documented best practices tuning recommendations. So make sure that you run the HealthCheck tool and take actions on any critical, error, and warning severity reported by it. This tool can be run against TrueSight version 10.7 and onwards. However, the tuning recommendation it suggests are based on the latest version only because it has been updated over a period of time based on the latest performance and scalability testing. There is a separate webinar recording available specifically on running and understanding TSOM HealthCheck tool. And there is a knowledge article available as well. I will include link of that webinar and knowledge article in the references as it gives more detail on all the checks that BMC HealthCheck tool performs. We often see that TSPS is tuned at the time of implementation but was not retuned as the same environment grew over time. TrueSight HealthCheck tool does provide a feature of emailing a report. So as a proactive measure, we recommend scheduling the task to email the HealthCheck tool report at a specific interval. You can take necessary actions based on the recommendations suggested by HealthCheck tool and avoid potential issues. For this demo, I will quickly show you how easily you can schedule a HealthCheck tool to run at specific interval and email generated report to administrator email address which is configured in TSPS properties. First thing you need to do is make sure you have downloaded the latest version of HealthCheck tool from this BMC FTP link. I have it already downloaded under my TrueSight pserver utilities directory. To email the HealthCheck tool, you need to run this TrueSight healthcheck.bat file with -email option. However, for email option to work, you would need to configure the email properties in the TrueSight pserver. I'll just show you which properties you can configure. So these are the properties: mail.from.address, mail server, mail.server.hostname, and mail.to.address. If these properties are not configured, then email won't work. So this needs to be set before you schedule a task to run the HealthCheck tool to email the specific report. Now I will just create a sample batch file to email the report, and then we'll schedule one task to run that batch file. I will give it a name as let's say email at city.pat. I'll edit the file. The content of file just needs to have the location where HealthCheck tool is located. So copy the path where HealthCheck tool is located, cd to that path. We'll put it in double quotes to avoid any issues with space, and then just call the HealthCheck tool with -email option. That's it. Save the file. Now open Task Scheduler on Windows. Create a new task. I will rename it. I'll give it a name as email HCT. I want it to run even when user is logged in or not. Set the trigger for the task to run. Let's say I'll schedule it to run on every Monday. And under actions, I will just give a path where my batch file is located. So that was under BMC software. Yeah, that's it. Save. It's asking me to enter the password as I have selected an option whether the user is logged in or not. Just to make sure that my task is running, I'll run it manually once. Yep, it seems to have finished. As you can see, the following HTML file is created, and if I go back to my email, yep, here you can see I have received an HTML report generated by the HealthCheck tool. So as you can see, this way you can schedule the task to email the HealthCheck tool report at a specific interval and take necessary actions based on the recommendation suggested by HealthCheck tool. This concludes this demo. As you can see, the following table provides a memory tuning guidelines for TSPS Java processes, core, and index server. For better performance, you can increase min and max heap of core process by 20% than what is recommended if your system has sufficient RAM. An important point to note is that the min and max heap for index server must be the same. If you set the max heap value for index server higher than min heap, it will not start. Depending on the TrueSight presentation server event retention and the rate of incoming events, the index server process may consume more RAM than what is set in the configuration. For example, for approximately 180,000 events retained in TrueSight presentation server, the index server process may require 1 GB additional RAM than max heap setting, and in an environment with 700,000 events or more, the index server process may consume up to 10 GB RAM. This is required for native memory or threads that are outside the max heap process memory. Any changes to this memory tuning do require a TSPS restart. In case of high memory issues, make sure that this garbage collection configuration is done on the TSPS. If you are using 11.303 or an earlier version of TSPS, we recommend making changes for garbage collection as shown in this table. Comment out the existing garbage collection parameter present in the csr.conf file located at TSOM conf services directory. The parameter that needs to be commented are shown in the first column of the table, and the one that needs to be added are shown in the second column of the table. There is a knowledge article available for this, which has more details. With these settings in place, the garbage collection happens every hour. We have seen an improvement in TSPS performance with the above GC settings in place. Hence, starting from TSPS 11.304 version, this is configured by default. In a large environment, if you encounter a slightly slower response time due to the large number of events being synchronized, set the event schedule period to 12,000 using the TSSH properties set command as shown, followed by the TSPS restart. This property controls the time period at which events are inserted into the Elasticsearch. When an event reaches TSPS, it gets pushed into a queue. That queue is polled based on the time that is configured for the event schedule period property, so that the bulk of the event will be processed at once and inserted into the Elasticsearch. The time period that we are configuring here is in milliseconds. When the TSPS is deployed on VMs, there are chances that you see some performance issues if the VM resources are overallocated. When the demand of one VM is high for the host to handle and the host is running out of physical memory, the memory ballooning occurs. It's basically a feature which allows host to artificially enlarge its memory pool of memory by reclaiming unused memory allocated to other virtual machines. However, if this happens for a long time and the VM which hosts the TSPS server doesn't get enough memory, it will affect the performance of TSPS. We do understand that VMs offer more flexibility and ease of administration. Hence, if the VM resources are available and not overallocated, you don't need to reserve the CPU and memory. However, when troubleshooting performance issues, BMC may ask you to temporarily reserve the resources to help in isolating the issue. We strongly recommend that you be on the latest version and hotfix available for the TSPS to avoid any known issues which are already fixed in the hotfixes. Moving further on the best practices checklist, we recommend to perform a self-health monitoring of TrueSight presentation server. By default, TSPS has inbuilt self-health monitoring, which monitors RSSO server, TSPS PostgreSQL service, index server, failover of high availability installations, components registered with the TrueSight presentation server, but only when it disconnects, database backup, and it generates the self-monitoring events. However, by default, self-monitoring email alerts are not configured. So make sure that you configure the self-monitoring email alerts. They will need to be enabled post-install by executing the TSSH properties set commands with the appropriate values. You can run the TSSH properties list command to check if those values are already set or not. In case of TSPS HA, this command needs to be executed on the TSPS node which is active. Changes in above property doesn't require a TSPS restart. You can just run the command tssh properties reload. In addition, we suggest the monitoring Java memory utilization of TSPS process. This can be done using Patrol for Apache Tomcat and generic Java Server KM. The TrueSight products are based on Java, so monitoring Java process helps you understand how the memory is being utilized by the process over a period of time and see the trend of memory utilization. This information can also be helpful for support and R&D team while troubleshooting any kind of performance issues. So let me quickly show you the Java monitoring that I have in place for TSPS core and index processes using GJSKM. So this is my TSPS host and I already have Patrol agent and generic Java Server KM installed on this host. The next thing you need to do is enabling the JMX port that is required for this monitoring. To do that, you would need to edit the csr.conf and the idxsrv.conf file, which are present under TrueSight pserver.conf custom directory, and add the JMX related properties in these configuration files. So if I open the csr.conf, I have already added this JMX remote.port, JMX SSL, which I have set to false because I have not configured the SSL and I'm not using any authentication, so that is also set to false. The main thing is this port number, so I've enabled this port number 3333 for this monitoring to happen. So with this, GJSKM will use the JMX RMI connection on this port in order to monitor this Java process. Same way for index server, I have added the property. For index server, I have used the JMX port 3334. This port will be required when you are configuring the monitoring policies. So while you are configuring the policies, you would need to give the detail of this ports which you have configured in this properties. I already have a monitoring policy in place, so let me quickly show that. Here I have created the monitoring policy for generic Java Server KM. I have added the monitoring configuration with monitoring solution, Apache Tomcat and generic Java Server. And the monitoring type that I have selected is generic JVM server setup. Here I have configured the core and index service process which we want to monitor, and added the JVM environment. Environment name could be anything. The host detail I have provided here is localhost because my Patrol agent and the TSPS are running on the same host. The JMX port details which I have enabled for core server, and the RMI server type which is JMX RMI by default. The same configuration is done for the index server as well. The only difference here is the port number, which is 3334. It's the same one which I have enabled for the index server in the configuration. The policy is already applied on the Patrol agent, so we will see what all data it collects. This is my TSPS host. If I go to the monitors, I can see the generic JVM monitor type is created, and underneath that the two processes that we are monitoring, TSPS core service and the index service. If I further expand the core service environment, You can see number of parameters that this KM collects. However, the main one that we are interested in right now is memory, which shows the Java heap memory usage by this process, and the other one is operating system, which will show you the CPU utilization by this process. If I open the heap memory usage, let me refresh the graph for last 2 hours. So as you can see, the Java process of TSPS core server is utilizing the memory, and at the same time it is also cleaning up the memory. So at this point here in the graph, you can see the memory utilization by the core process was around 21.92%. Within 5 minutes it reached up to 36.39%, and then it cleaned up the memory. So all these mountains and valleys that you see in the graph are basically indicates that the memory is being used by the core server, but at the same time it is also getting cleaned up time to time. So the graph looks pretty healthy, and it's not like that the process is continuously using the memory and not releasing any unwanted or unallocated memory. If I go back and show you the operating system, which shows the CPU utilization, I'll select the single metric, process CPU utilization. So this graph will show you the overall CPU utilization by this TSPS core process over a period of time. So with this data, you can see the overall trend of the heap and the CPU utilization by the core and index process, which will help you in determining if there are any tuning that needs to be done in your environment, or if the memory utilization or even garbage collection is not happening properly. This concludes our demo. Next, in the TSPS self-health monitoring, you can monitor the TSPS database PostgreSQL and Elasticsearch. You can use Patrol for PostgreSQL KM to monitor PostgreSQL DB, and Patrol for Elasticsearch KM to monitor the Elasticsearch health. Please note, to monitor the Elasticsearch database, you need to configure Elasticsearch to listen on port 9200 by setting the configuration variable http.enabled to true in elasticsearch.yml file, which is present under TrueSight Home Modules Elasticsearch config directory. With this monitoring, you can monitor the overall health of Elasticsearch. Now let's see what all data you would need to collect for customer support to troubleshoot the issue. In many cases, during high memory and CPU utilization issues, restarting the TSPS service might be an immediate workaround to fix the issue temporarily. However, with this approach, we lose the opportunity to collect the data that can help us to identify the cause of issue. So in such high impact situations, even if you decide to perform TSPS restart, it's best that you collect following data before TSPS is restarted. In case of high memory and CPU utilization issues by TSPS, please collect the thread dump of TSPS processes, index and core server. You can collect the thread dump of process using the JStack utility, which comes with the JDK. Starting with 11.3.04 version, TSPS does include the JDK. However, for earlier version, you would need to install the JDK separately on the TSPS server to collect the Java thread dumps. To get the histogram of the heap memory, JMap utility can be used, which is also included in the JDK. In case of any issues with the console, enable the TSPS debug for 5 to 10 minutes and collect TSPS dump using tssh dump export command. For console slowness issue, you can also collect the browser developer tools output. I'll show you a quick demo of how this data can be collected. So let's see what all diagnostic information you can collect for support to troubleshoot and identify the cause of issue in case of high CPU or memory utilization situations, or even the slowness issues. So let's say if you're seeing the high CPU and memory utilization issue on your TSPS server and also facing slowness on the console, then the data that you can collect is thread dumps, JMap histo output, the complete dump of TSPS, and the HealthCheck tool output. So to collect the thread dumps, as I mentioned earlier, you can use the JStack utility. If you go to the TSPS server and if you're using 11.304 version, then you will find the JStack under TrueSight presentation server modules JDK. So this JDK is already included with the TSPS 11.304, and here you can look at the JStack and JMap utility, right? So to collect the thread dumps, you need to have the process ID of the process, which is using the high CPU. So in order to identify the PID of process, you can run tssh server status command that will give you the status of processes that are running along with its PID. So we can see that the PID of core server is 3180. To collect the thread dump of core server, I would run just check -l 3180, and I will redirect its output to, let's say, under C drive td1 underscore core.txt. When you're collecting thread dumps, you would need to repeat this step at an interval of 2 to 3 minutes for minimum 4 to 5 times. So you can run the JStack again, collect another thread dumps at an interval of 2 to 3 minutes. This way we'll be able to identify the threads that are getting blocked for a longer duration and which can cause the high CPU utilization. The next data that you can collect is JMap histo output. So I'll run the command jmap-histo and then the PID of process. We'll store it under C drive. The histo output will basically gives us the detail about class objects for that specific Java process which are loaded into the memory. It will also gives the information about the size of the class or the object in bytes. So after collecting this data, you can take the complete dump of TrueSight presentation server by executing tssh dump export command. This command will archive the database, TrueSight logs, configuration, Tomcat logs, Tomcat configuration, everything that is required for us to troubleshoot the issue. Along with this information, you can also run the HealthCheck tool and zip all the data for support to troubleshoot the issue. So as we can see, it has completed the dump and it has copied it under TrueSight piece our temp directory. So it's available under this directory. So all this data you can zip and share it with support. Now let's see if you are facing this slowness issue. In that case as well, you can collect the thread dumps and JMF histo output as well as dump. But before taking the dump, in case if you are seeing the slowness on the console as well, then you can enable the logger for all the debugs. You can enable the logger for TSPS by running tssh logger debug on -n all. This will enable the debug for all the components of TSPS. So if you check the tssh logger list, you can see it has enabled the debug for all these loggers. So after enabling debugs, another information that you can collect, which needs to be collected from the browser side, is the browser developer tool output. So if I go back to the console, so after login to the console, if you, let's say if you're seeing a slowness on events or any other page, you can open the browser developer tools by clicking F12 on your keyboard if you're using Chrome, So that will open the browser developer tools on the right hand side. And then you can go to the page on which you're seeing the slowness. So let's say if you're seeing a slowness on events page, then click on events page. And as you can see, it will load all the calls that TSPS is making in order to load this page. So this data you can share from the browser by clicking on one of the web service call. Right click, save all as HR with content. So along with what all data you have collected from server, you can share this HR file as well that you have collected from browser for us to troubleshoot the issue. This concludes our demo. TrueSight presentation server has a troubleshooting section in the documents. The purpose of this troubleshooting guides is to understand, identify, and self-solve the issues. And if you are not able to self-solve them, then you will already have a data needed to open a better support case. As highlighted on this TrueSight presentation server page, you can see the troubleshooting section is located in the navigation pane as well as the link highlighted on the bottom right of the screen. This troubleshooting page contains all known issues related to TSPS, including performance issues. We will now go through some of the common issues related to TSPS performance. We have seen an issue where the event page on the TSPS console takes about 5 to 6 seconds to load or refresh the event view, even when only 100 events are present. While scrolling down the list of events and at every 100 new events added, the refresh time increases on and on. For example, it takes about 35 to 40 seconds to load 1000 events. The issue may not happen in all the environment. However, if you encounter this issue, as an immediate workaround, you can control the number of events displayed on the event page. This can be controlled from View Event Preference option, which is available on the Monitoring Events page. Increasing auto refresh interval for events page will also improve the overall performance. The number of columns displayed in an event table view also has a huge impact on the time that event page takes to load. For example, if you have an event table view with the 15 to 20 columns or more, the event page will take more time to load than what it takes when the event table view has 10 columns. There is an open defect in this area for TrueSight 11.3.04, which is already in pipeline. Sometimes when you upgrade from an older version of TSPS or apply a fixed spec, you might see a blank screen when you log into TrueSight console. This problem mainly occurs when one or more WAR files available under TrueSight Home Modules Tomcat WebEx directory is not extracted correctly. As a first step, you can try clearing your browser cache and cookies and access the console and see if that works, or try accessing the TSPS console from browser incognito mode. If you still see the issues, log into TSPS server, stop the TSPS server, then go to TrueSight Home Modules Tomcat WebEx directory and delete all the directories present except WAR files. Make sure that you do not delete any WAR files. Start the TSPS server. The deleted directories will get automatically extracted from WAR files. Starting with 11.3.04 version, we have seen a number of issues related to high CPU utilization by TSPS core server process, and there are multiple defects created for this issue, which are listed here. All of these defects are already fixed in the latest hotfix available for TSPS. So if you encounter any high CPU utilization issues on TSPS, first thing to make sure that you are on the latest hotfix available for TSPS. And if that doesn't fix the issue, collect the data that was presented in the earlier slide and raise a support case with BMC. There is a common issue where TSPS startup time increases and it also affects the TSPS performance due to large number of entries present in the Petrol Agent PCF GTL table of TSPS database. TSPS server stores the policy configurations that are applied to Petrol Agent in the PostgreSQL database table. The default count for all versions prior to 11.304 is 10 historical configurations. In 11.3.04, the default is 3. In large environments with many patrol agents and large pconfig variables, this can cause a performance issue due to the size of the table which is loaded into the memory. Truncating this table will help in improving overall performance of TSPS server. The knowledge article mentioned in this slide contains all the steps that needs to be performed to fix this issue. There may be a scenario where TSPS server fails to start and you see an error, failed to create a database connection in the TrueSight.log file. This is a very generic error and it can have multiple causes. The knowledge article referenced in this slide lists all the possible causes for this issue. Here I have highlighted some most important ones that you can check. If the TSPS is hosted on Linux, make sure that you have number of open file descriptor limit set to 2048 or higher. Confirm you have adequate free disk space on the machine. To avoid any DNS related issues, specify the IP address instead of hostname of the TSPS in pg_hpa.conf file located at TrueSight home data pgsql directory. Add the TSPS hostname entry in the etc host file in case of Linux environment. For Windows, it needs to be added under system32 drivers etc host file. Make sure that the ping to localhost is working fine and resolving to loopback address. This reference slide has link for the TSPS performance tuning, sizing and scalability consideration, troubleshooting performance issues, TSPS self-health monitoring and the HealthCheck tool. It contains some additional information from what has been covered in this webinar. To summarize the webinar, we have covered an overview of TrueSight presentation server. We covered all the best practices to tune and optimize the TSPS performance and self-health monitoring of TSPS, information that needs to be collected for support to diagnose the issue, and some of the most common issues that we have seen in this area. That concludes my presentation. Back to you, Greg.
Thank you. And now I'll take us through the self-help and contacting BMC. The YouTube channel where this webinar will be posted is available at this link. It contains past webinars as well as a rich set of how-to videos. The Connect with TrueSight webinar schedule that contains future webinars as well as our past webinars is available at this communities link. Also, the Hot Off the Press newsletter contains trending information. And to contact technical support via web, phone, email, as well as these social channels are available through these links. That will conclude our session today. Thank you for attending.